Hi everyone, welcome to the video. This video I'm going to be using my new USB foam cutter to make some new blades for a gyrocopter, or AutoGyro as they're sometimes called as well. And as well as making some new blades, I'm going to be making a new rotor head for it and some smash parts with the 3D printer in ABS. So it's going to be some foam cutting and some 3D printing. So if that's interesting to you guys, then stick around and let's see how it goes. Right, so you may ask why do you want to build some new blades? Several years ago, I bought a plan for an AutoGyro from a guy called Richard Harris. He's well known in the AutoGyro world, and he's had quite a few plans published as well, radio control plans. And I bought one called the RPG. Sent off for the plan, it came and it was brilliant, the plan, but it looked a fair size model, and I'll put a picture up of it of some of them so you can have a look at it. And when I got the plan, I thought, well, what's the chances of me building that and not crashing it first time out? So I thought probably start a bit easier. So at the time, Hobbyking had just brought out a new version of their AutoGyro, the G2, and that's got a pre-rotator on it. So that, see that little shaft going up there, and that actually spins the rotor head, and it's got a separate little motor in there, and then it freewheels afterwards, and that spins it up and makes it easy to take off. I never had any problems taking it off. It seemed to take off reasonably well, but once I got into there, I seemed to lose orientation with it, and I think basically I was trying to fly it like a fixed wing. Well, after 3 sets of blades, 2 props and various other parts for it, I gave up with it. I'd spent more on the spares than the actual model itself. So I'd even decided to convert it to a fixed wing, and I made a foam wing for it, and I've still got the wing. I haven't progressed with it any further. This has been sat on the shelf for about a couple of years now. So a little while ago I got the bug again for AutoGyros, and after watching some videos on YouTube, as you do, you watch something and think, well, I wonder if I can do that. Probably my failing, that is. See things that I think I can do. But I thought I'm not going to be spending out on all these blades again. So I wondered if I could make one with the USB foam cutter that I've got on the website. So this is the new USB foam cutter, and I've got a full video tutorial series, and there's a free ebook that goes along with it. I think there's a free ebook there, and there's also some full-size plans. There is a small charge for the plans. It's only $5. It just helps me to keep the website running and keep buying all these parts for the CNC machines. So and they've gone down quite well actually, and I've had some good feedback from them. What I'm going to be doing is using the new foam cutter to see if I can make these blades. And I've done some initial testing and it's worked out quite well. As well as making the new blades, what I'm going to be doing as well is trying to modify them so in the event of a crash, stand more of a chance. And from doing some research, and I'll put a few pictures up in a minute, from doing some research, most AutoGyros that you see just tend to use a single bolt in the edge of the blade onto the rotor hub, but the Hobbyking AutoGyro G2 doesn't. It uses 2 small screws and some wedges to put some what's called negative incidence on the blade. So I've decided to build a new rotor head with the 3D printer in ABS, which has worked out really well, and attach the blades with just one screw, and so in the event of a crash they fold back. And so I'm looking at some videos on YouTube. When people have crashed with them, the blades seem to fold back and survive fairly well. So that's really what this video is going to be about, is how we can make some new blades, a new rotor head, and then I'll probably do it in 2 parts. So the first one will be all the building side, and then the second video will actually go out and maiden it and see if I can manage not to crash it this time. So if that's something that interests you guys, then carry on watching and we'll go through the steps. So what materials are we going to need to make these blades? Well, we're going to need some foam. I've used the pink XPS foam, which is a denser type foam. The white foam that we can get is not going to be good enough for this. It's just the cells are just not close enough. We're going to be cutting a slot in here to put a strengthening spar in. And I've used some 3mm fiberglass round that I've had kicking around, but 3mm carbon spar would be fine as well. And then to give the wings some strength, what we're going to do afterwards is cover them in brown paper and PVA or white glue, sometimes called Elmer's in the US. And I've covered lots of wings with this, and it makes an amazingly strong wing. So from a sample blade I made, I put a carbon spar in there, and then covered it in brown paper and PVA, and then gave it a coat of sanding sealer. The blade's incredibly strong. I almost bent it double, and it hasn't broken. So I think they're certainly going to be strong enough for this, and I think they're actually a little bit lighter than the Hobbyking blades as well. So the other thing we're going to need then is a way to cut the blade, and as I said earlier in the video, I'm going to be using my new USB foam cutter. So this is what I'm going to be using. That's my old design underneath, which is similar but uses older technology. But so I'm going to be using this here to cut the profiles in the foam. But to do that, we need some software, and there's a few different pieces of software we can use. The one that I've used mostly in the past is one called Profili, but that's no longer available. It was paid software, but it's been superseded now by DevWing Foam, and I've upgraded that. But we have got some free options as well. And one of the free options we've got is CNC wire cutter wings in Gcode. This is by a guy called David de Swarfer, and basically this is an online version where you can put all the dimensions in, and it will generate the Gcode for you. You just need to register on there, but he has got a standalone version that you can download as well, and we've also got some links to where you can get some aerofoils from. So that's a good one to use, and it's quite suitable for what we're doing here as well. And another option is one called Jedicut. So Jedicut is another free version, and I've got videos on using both of these, so I'll link you to a video. The first half is about cutting a swept-back wing, and then the second half goes into Jedicut as well. So I'll put links up to them videos as well, so if you want to use that instead. But what I'm going to be using is DevWing Foam. So if we just bring DevWing Foam up. This first little splash screen takes a little while because it's checking for a license. If you haven't got a license, you can do nearly everything apart from generate a G-code. So if you want to just try this program out before you commit to buying it, then you can do that. As I said, it's not a free program, this one, but personally I think it's well worth it, because you can make loads of wings, and I've made loads with Profili, and we'll be making a load more with this one as well. So you can see I've already done one already, but we'll do a new one. So we'll create a new project, and on DevWing Foam, any window that's got a red line on it means that it's mandatory, so we have to put some details in there. So we'll call this AutoGyro, call this demo, and we have to put some settings in here. So half wing length, this is going to be our blade length, so the blades are actually 370mm long. And with DevWing Foam, there's lots of options on here that we're not going to need. We can even just take this expert mode off as well. For doing this blade, we only need a few of these options. So you'll see a lot of it we won't be doing, but I will be doing a full tutorial on DevWing Foam in a later video. So keep an eye out for that one if this is interests you as well. So we can leave that half wing. We don't need to do anything with that. The chord length is going to be 50mm. Well, that's going to be 2 inches. And then we've only got one panel, and this wingtip option we don't need either. I'll explain that in the later videos. And then we go to next. This option here is for more complex wings, where you can put an image in here, and if it's like a complex wing that's got different sections, it will actually generate the panels for us, as it calls them. So this again is a mandatory screen, and what it's actually done, it's made a tapered wing for us, which we don't want. So we just put 0 in the sweep back, and then if we put 50 in the tip core length, so we just apply that. Oh, it's gone back to 25 there, 50. Apply that. So now we've got our square wing, and you can see there's quite a few other options here that are designed for when we're using more panels, and but that's all we need in this one. So it is 50, yeah, it is 50 that. So we'll go on to next, and we can split the panels if we want, but we don't need that. You can see it's optional with it being yellow. So this is a mandatory screen, and this is where we need to specify the airfoil we're going to use for this. Now, from my research I've been doing, it looks like a lot of gyrocopters use the Clark Y airfoil, and I found a video with a guy that actually built some blades for the AutoG2, and he used an airfoil called the Aguila, and he says it flew tons better. So I'm actually going to give that one a try. So on DevWing Foam, what we do is we go into the root airfoil, select, and it's this one here called Aguila. I've got a filter on here, but you can see I just take the filter off. In DevWing Foam, it's got hundreds of airfoils in here, and if it hasn't got one that you are after, you can import one, and there's quite a few places you can get airfoils from as well on the internet. I'll put some links in the description. So what we'll do is we'll just go for that Aguila again, and we can preview the airfoil as well. So you see it looks very much like a Clark Y, but I think it's a little bit flatter at the bottom. I think the Clark Y has got a slight camber on the bottom. So we select that one, and then we select the same for the tip. This section here, interpolated, what that means, if we've got more than one panel in here, and all we have to do is specify the root and of the first panel and the tip of the last panel, and it will work out all the others. So we haven't got to go through and specify each one, but we'll cover that in a later video anyway. Right, so the other thing we do here, if I now apply that, and if we now look at the panel A, which is the root and the tip exactly the same, there's no difference there. So what you'll notice down here is the airfoil comes to a point down here. Now when we cut in that in the foam cutter, what happens is this can get very thin, and it can burn away the actual foam itself. So there's a good option in DevWing Foam, and it's this one here, trailing edge thickness. So if we go into there, it says define it for each panel, but we've only got one panel. So, and then what I found through testing is 1 millimeter there, and if I apply that, and if you watch at the tip now, you see that's expanded there. It looks a lot more than 1 millimeter because this is only a small blade, but that stops it from burning away to nothing. And through the testing I've done, that works out quite well. Actually, we've got loads of other options in here, dihedral and washout, but we don't need them, and I'll cover them in the DevWing tutorial. So I'll go on to next. So this is optional, and most of these other options we don't need any of these now. We've done what we need, so we'll just carry on through them. So that's saved that part of it. So now we've done the design phase, what we need to do is actually create the cutting project. So we just go, so we select our project there, and what we want is this option here, create a foam cutting project from the selected project and save it. and this is what's going to actually generate the G-code, so we can cut our wing, cut our blade. Keep calling it wing. Right, so we select that, and this is what we've done in the design part. So we've only got one panel in there. So, but what I like about this DevWing Foam, I can actually put 3 in there, so we can cut all 3 at the same time. Now, if you've got a swept back wing, you'll need to cut a left and a right, because if you cut 2 rights, you'll have a wing that won't look quite right. So so it doesn't matter which one of these we do, because this is just a straight wing. So what I do, I put it in 3 times, and that allows us to cut all the blades at the same time, rather than having to set each bit of foam up. Right, so we go on to the next. And this is where we set the speed, the curve values, and the cutting strategy, which we don't need to mess with in this one. The speeds I found here are absolutely fine, but what I did find was the curve value needed altering. Now the curve value is the amount of foam that's going to be melted away by the cutting wire. So you can see here we've got 2 values, we've got root and tip. Now for this straight wing we have it both the same, but if you're doing a swept back wing, the tip edge tends to be smaller, so the wire will be traveling slower and it tends to burn more away. So what you would normally want to do is have a bigger value there than you do at the root side. But what I have found is, and with the temperatures I've set in the machine, I've needed to make this a little bit bigger, so I've changed this to 3 millimeters, and then we have to apply that to all these curve values to all items in the tree list. So that's done that. So if we expand them out, we can see we've got curve for the root and curve for the tip of the same. And that's really all we need to do on this page as well. And it looks, from my testing, it's worked out really well. Right, now this section here, setting the cutting order and foam block size, it goes in from the top anyway, so we don't need to change anything there. But what I have done is I have altered the values here to make these a bit closer, because I said earlier I'd only got 1 piece of foam left that was just big enough to do this. So what we do is we select the bottom one and go into the top dialog there, and all we do is I just lower the space underneath to 5. So that brings it down a bit, and we just do it for each one. You can alter the others as well if you want to get even closer, but you don't want to get too close, as they'll start running into one another. So if we apply minimum size there, and there we can see that's telling us the minimum size of foam block we need. So I think I used about 70 by 80 when I did the actual cutting of the foam. Right, so that's all we need on that one. And this is the placement of the foam in the machine. Now, what you can do is you can set your machine up here. So this gives the distances of the gantries from each other and the X and Y travel. So my machine is set at 1000 millimeters or 1 meter, and then I've got 600 on the X and 400 on the Y. So but if your machine is different, you can change them values there. So that's where it's going to place the foam block in the machine. But if you're doing a swept back wing, you need to make sure you get it in the right position. Otherwise, you can end up with a wing that's either smaller than you think or bigger than you think. But we'll cover that on a later video anyway. So the other thing I do here as well, as you can see here, looking at the side view, it's actually got the foam block 10 millimeter up and 10 millimeter from. But I like to set this to 0. See, that comes down, and I get my wire as close to the block as possible. See, it's got a little bit of leading on there as well, so it'll be fine on that. So go on to the next screen. This screen here is actually pre-cutting the foam block for us to the right sizes. So you can either do this manually or let the machine do it. So from the sizes that it's given us, we can cut the block to that size, or we can let the machine do it. But so we don't need that in this. And the first thing I like to do when we get to the final page here, where we actually create the cutting file, I just like to save the cut project first. See, I've done this before, so I'm just going to replace that. And then what we can do is we can view them. So that tells us the size of foam that the minimum size of foam we would need for that. And then if we go back, we can do a simulation. And we've also got the option there. That second option at the top there is where we could cut the foam block to the right size if we wanted to do that, and we would have two cut projects then. So we just look at the simulation, spin it around a bit, and these grey here are the available paths for the axis. I'll just take them off, it's a little bit easy to see, and then we'll just zoom in a bit. So this is the path the wire's going to take. And for a straight wing, it's the same as the actual path of the aerofoil as well. But when you're doing tapered wings, this end will be bigger and that will be smaller, and vice versa when you do the other wing. So what we'll do, it always starts at the end. We'll just run it back to the beginning. It's quite good sometimes to do this simulation section so you can actually see what it's going to do, rather than get out to the machine and think, oh, I didn't expect it to do that. So we'll run the simulation and just see what it does. So to run the simulation, all we do is we just press the start there. There we go, hit the wrong button then. You see it's going quite slowly, but if we press the, we'll zoom in a bit as well. The more you press that, the quicker it goes. So you can see it's starting the top one. Now what we don't want it to do is start the bottom, because what will happen is as it cuts the bottom one out, there won't be very much foam supporting the rest of it. So the whole foam thing will become a bit wobbly. So we do the top first, and I screw. And what I do is I stick the foam down with some double-sided tape on a support block. So I've actually done this already, and it worked out really well. So that's a simulation. So what we want to do now is actually create the Gcode file. Now, if you've got the demo version, you haven't bought a license yet, when you go to select this, you won't be able to go any further. You can run the simulations and everything okay. But this is where it will check so you've got a license, and this is where we can change the axis letters if they're not right for our machine, but this is right for the machine we're using. And we can also switch the hot wire on and off. It does work on the new machine with the Arduino and the ramps board. It works really well actually, but I just prefer to know the wire's hot enough myself before I set the machine off. Right, so all we need to do now is actually get it to generate the Gcode. And I just leave this as it is, I don't need any more options in here. So we just go OK, and then I've got it saved in a directory here. I'll just overwrite this one, 3 Blades Demo. And we'll save that. And then if we go and have a look, and I use Notepad++ to look at this. It's a real good text editor. So this is the actual Gcode. Not very exciting stuff, but without it wouldn't be possible, as they say. So you can see there's loads of it in there. and it does work really well on the machine. So that's the design phase done. So what we need to do now is go out to the machine and actually set it up and get it to cut these blades and see how that goes. So we'll see you there, guys. Right, so let's see if we can get these blades cut for the AutoGyro. So I've been doing quite a lot of testing for the last hour and a half or so to get the temperatures that right. Hopefully I've got it right. This is the only piece of foam I've got left that's going to be the right size, so hopefully it goes well. So let's see how we do. So it's going to come up and do the top one first. So it's going to be cutting 3 blades out of this. And it's slightly longer than it needs to be. It's about 380 at the moment. It needs to be 370. So I've just left a little bit on there for just to trim the ends off nice and square. So here we go. You can hear it sizzling. I've had to alter the kerf value quite a bit. So let's just have a look at the wire, make sure it's... What I'm looking for is to make sure the wire is not being dragged. So when I look down over it, it should look nice and straight. Which it does. I'm very close just getting that blade out. It's come right to the edge of the foam. Just zoom in and have a... That's the first one done. It's now coming down to do the next one. Let's see what these look like. And the foam's just been held down with double-sided tape. So let's have a... Yeah, so that's not looking too bad. Once we get it, get the spar in it. So we'll just leave them in there for protection. Made that a bit wide there, just getting the camera in, but that'll be okay with some. So that should fit in there just right. So these are all the parts to repair the AutoG. So I've put this is the sample blade I made, just as a quick test, which worked out quite well. And this is the original blade, so I've just put that in for comparison with the, so that's the only one I've got left from the, and even that's a little bit damaged. So these are the blades I've made, and you can see that from the previous bit of clip, I've got the carbon rod in and then filled them underneath. And then what we're going to do then, and on this one already, I've already stuck a piece of balsa on there. And the balsa is going to just provide a little bit more strength there, and it's been glued in with Yoo-hoo pour. And so the intention is that piece will go on there, and this is just some light ply. I think it's about, let's just measure it. I think it's about 1.5 or about 1 millimetre. Yeah, it's just a 1 millimetre light ply. And then that's going to go onto there. There'll be one underneath, like that. And then once I've got the blades balanced, so we need to balance these blades. Once I find the balance point, then we'll drill a hole 1mm back from where the blade balances on the cord. And then what I'll do then is, these are some small bits of aluminium, and they'll go, so I'll drill the hole for that to go in, and then the bolt and the washer will go in, and that'll hopefully, in the event of a crash, that the blades will fold back, so I'll stand a bit more chance of learning to fly the damn thing. So the rotor head's been made, and that's worked out really well with ABS. I've been quite amazed how well I've got ABS to print, and if there's enough interest, I'll do a video on how I've got my ABS to work. And it's only on one of the cheapest printers you can get. It's the Anet A8, which you can just see in the corner there. And I've made a few mods to it, but nothing spectacular. And so I think I'll be printing a lot more things in ABS. And the other thing I've done as well is I've printed a new mount, because on the previous, let me get the parts. On the last crash, I think it was the second crash probably, you can see that's broken, and and I've glued it a few times, and you know, it's never as good. So looking on Thingiverse, a guy had actually loaded an STL file up for one of these. So I printed this one off, and I just did it in 20%, and it's pretty strong and it's okay. But the only thing is, where the holes go, there's no strength there. So I have printed another one. I've actually got it mounted in now. So on the other one, that's actually mounted in. And what I've managed to do is, I found a good tutorial on Google by a guy called Chep, I think his site's Filament Friday. He's got some great videos on there as well. So what I've done is, on that part there, I've managed to print that 100% and leave the rest of it at 20%. But the only difference between this one and the one from Hobbyking, let's get this up and see if we can see it. The Hobbyking one has got a bit of down thrust in it. So try and hold them side by side. And this one is dead straight. And I did try modifying the design, but it started getting a bit too much. So all I've done is I've attached a couple of washers to the top to give it, and it's more or less the same angle on there. So that should give us the same amount of down thrust on there. And the other thing, because I've broken the 3-bladed prop, I'll be using this 2-bladed. Now the original prop is a 10x8. So usually what you generally do, and there is some formulas to work it out more accurately, but what you tend to do is, if you're going from a 3 to a 2, you go up on a diameter and down on the pitch. So it was a 10x8, so this is an 11 diameter and a 7 pitch. So I haven't actually tried that. So what I'm actually going to do is put the watt meter on, and then just check the current draw on the speed controller, because the speed controller, it's just a 20 amp speed controller, and I think possibly that might draw a bit too much current, so we'll have to do that. And if it does, I'll probably just go down to a 10x7. I don't want to buy another 3-bladed prop from Hobbyking. I think I bought 2 of them already. So what I'll do now is I'll do a time lapse of the covering of the wings with brown paper, and then so after the brown paper's on, what I'll do is I'll put a coat of sanding sealer or non-shrinking dope. I think I've got both, and that gives it a smoother finish then. The only problem with this test one I didn't do any filling on the bit of foam, and you can see it is a little bit ripply. So on these I have gone on, given them a very light skim of lightweight filler, and then once the brown paper gets on, that should be smoother, and then I'll give that a light rub down, and then the sanding sealer, and hopefully this will work. There's only one way to find out, I suppose. So what we'll do, we'll get on and we'll do a time lapse on the covering of the blades. I've got a longer video on covering wings with brown paper and PVA, and it seems to be one of the most popular videos I have on YouTube. It's a good method of covering. It's best of all, it's cheap, and it's amazingly strong. So once you get a bit of carbon rod in there and get these on, and once it dries off, it's incredibly strong. Of all the wings I've made and flown, when I've had a crash on any of them, it's never been the wing that breaks. It's always somewhere else that breaks. The wings survive really well. So guys, what I'm going to do is cover one of these blades, and then the other two I'll just do as a time lapse, or depending, I might not even just show them done. So I've got, as I said, I've got a longer video showing you how to do all this, but I'll do these blades and I'll talk you through the process. It's quite easy. So we'll just get this camera refocused and right, so the blades, they've been rubbed down now, and any little nicks and dings have been filled, and then we've got these extra balsa pieces on the end. Yeah, so this is just brown paper. I've heard guys that have used wallpaper and even used Christmas wrapping or birthday wrapping paper, but I've used this all the time, and you're better off getting the non-recycled stuff. The non-recycled stuff works better. Some of the recycled stuff doesn't seem to work quite as well. So what you've got a shiny side, and then a side that looks more matte. So this is the side where we put the glue on, and the glue, all the glue is, it's not lemon curd as it says on here. It's white glue, PVA. I think in the States it's sometimes called Elmer's glue, and I mix it 50% with water. It's quite a messy job, so you need some rags and that ready. So I'll just put it on, and then get a felt tip paper, and what I use then is something to space it out. But this is fairly easy, this one. So I'll just mark it. Let's bend that down out of the way. Probably can't see what's going on there. Right, there we go. So what I tend to do is just, and this might actually be a little bit big, I'm just going to mark it there where it goes over. I'm just going to fold it over and then do it exactly along there. You'll see why as we go a bit further on. So that's what we need to do, is cut that out first of all. There we go, got that one off. Right, so now we've got that, what I want to do is I want the overlap to come underneath. You do get a very tiny lip, but it's next to nothing. And what we'll do then is we'll actually, if there is any lip there, we'll just put a very thin skim of lightweight filler, and that will take it away. So next comes the messy bit. So I've just got a small brush here. That's all I'll do now. Is we just go over the and don't be tempted to do one side, let that dry and come back and do the other side, because what will happen is you'll find it will warp. I've seen that happen. A friend of mine, I think I've mentioned this on one of the videos, a friend of mine built a Lancaster bomber, and he covered the wing, and because it was such a big wing, he did one side one evening, and then came back and did the next side. And when he came back in the morning, the wing was warped. He covered it. I don't think he realised he'd warped the wing at the time. He covered it, and I think it only lasted on its maiden flight and then crashed. So yeah, try and make sure you do them all at once. So if you're doing a big wing, cut 2 pieces, and you'll see that in my other video, and make sure you do it that way. Right, so what we're going to do now, we forgot there, we need to put some on here. These blades don't look very strong at the moment. I mean, they have got a carbon spar that you can see down there, but once we get this on and this dries, we'll be amazed at the strength. Still amazes me every time I do it. Right, so I think we've got plenty on there now. Right on the edge there. And then what I do is pick it up. And what I find very useful here is an old credit card or phone, or any sort of plastic card, and these are quite easy, these blades, because they're just straight, and then just pull it over, with a little bit, not too much because it will rip. Just try and get rid of any wrinkles. So you've got a little bit of one forming there. So don't be too worried if you do get wrinkles, because nearly all of them will come out if you have got any. Right, what I tend to do as well now we've got that flap to go over, I just put another right, because this is all flat, we can do a nice and then you just push it on, and you can see the excess coming out there, and that's making it nice and tight. What we need to do now, I normally fold the ends over, but I don't think I'm going to bother on this one, because on these, what I have done is put a very thin piece of light ply on the edge there, just to protect the edge. So I think I'm just going to do it square. I think that will do for the edges. We can tidy them up. Right, so what we do now is just give it a coat of the same PVA. Just go all over it now. And when it dries, it will just all tighten up. Right, so then we need somewhere to put it. So just through this end, I'm just going to put a pin through the balsa, and then leave it to hang there. So there we are, guys. All 3 are done now, and as you can see, there looks to be a few wrinkles, but we'll leave them overnight, and I'll be very surprised if there's any still left in there. So this is the non-shrinking dope I've got, which we'll be putting on, and I think I've run out of sanding sealer now, but this is just as good, and it gives it once these are dried, we give it a very light rub down. If there's any imperfections, just a little bit of lightweight filler and a rub down with some smooth sandpaper, and then a coat of this on, and it'll be strong. So you can see that one there, that's got a bit of a shine on it, that's because let's actually try. See, that's got the bar in it now, and you can see how far I'm bending it. So I don't think the Hobbyking ones would do that. So we'll see how that goes. I've damaged it a bit there as well. You can see I drop something on it, but so we'll come back in the morning, have a look at them, and hopefully they'll be good blades. So here's the blades all dry now, and they've come out really well. I'm quite pleased with them. There's a slight little lip there. I can barely feel it with my finger where the paper's been overlapped, and they feel quite strong now. So all we've got to do now is get the strengthening pieces on. Top and bottom, and then we'll give it a coat of this sealer, this non-shrinking dope, so that'll give it a nice shiny finish. And then what we've got to do is balance the blades then, and once they're balanced I can drill the holes and we can start to get mounted up. Not sure how I'm going to finish them yet, whether I'm just going to paint them or I could even cover them in film as well, but so that they're looking pretty good. So on to the next bit. Well, here it is, all finished. As you can see, I've got the blades on, and in the end I decided to cover them with white solar film. They haven't come out as good as I'd hoped. So I think the problem was I had the iron too hot. I forgot to check the settings on it. I realised by the time I got to the third blade, which I think was probably this one, and it came out a little better. But it's now on with the ABS 3D printed rotor head, and it's been mounted on with some screws. I'll just get a bit closer so you can see. So if you can see under there, it's on a single pivot now, and then it's got washers either side, and the blades will actually move. So I'll put it down and show you. So the blades, they're reasonably tight, but in the event of a crash, hopefully they should fold back and I stand a bit more of a chance of learning how to fly it. And what I've done as well is I've tested the prop with the watt meter, and what I found, it was pulling about 18 amps, and it was a 20 amp speed controller, because the original prop, if you remember, was a 3-bladed prop. 10x8, and this is 11x7. So what I've actually done is I've put a slightly bigger speed controller in. So I've got one of the Hobbywing speed controllers in there, a 25 amp speed controller. And there's actually 2 speed controllers in here. Yeah, that one there, you can't quite see it too, but that's a speed controller that controls the motor in there. I have actually got a spare one of these because I managed to break one of them with my first. So I bought a spare one of these. I can't remember why I bought it now, but you can see that's actually got the speed controller on it there as well. So and that's the flexible shaft, and you can see it allow you to turn it one way, but if you try and turn it back the other way, it won't go. Well, it will, but it turns the motor. So I've got a spare one of them in case we need it. And it just runs off a little 1300 3S battery. I've used these on quite a few things. I use it on my MiG-29, which you've probably seen on one of my videos. Pre-rotator plugs into the balance lead. So when we get down to the flying field, I'll show you that working. the weather's changing a bit in the UK now. It's starting to get quite cold and windy, so I'm ideally looking for a reasonably calm day. Probably about 5 or 6 mile an hour winds. There's a possibility, so this is Saturday, so there's a possibility on Wednesday I might be able to get it to fly. So we'll see how that goes. And if it all doesn't go so well, hopefully these blades will survive a bit until I get used to flying these things. So I'm quite keen to fly an AutoGyro. That's something I've always wanted to do. I don't know why, it's just one of them things that sort of grabs you. Keep a lookout for this video. If you watched the whole video, guys, thanks very much for watching. It's been a bit of a long one again. The next video will hopefully be this flying, weather dependent. But if not, what I'm going to start working on now is a DevWing Foam tutorial, and that's the software that you can use to make wings and that. So you'll have seen in this video that we've used DevWing Foam to make these blades, but probably DevWing Foam really was a bit of an overkill for these, because these are quite simple blades. But when we get on to making more complex wings, and I think what I'm going to do is I'm going to do a flying wing again, but probably a bit bigger than I've made before, and incorporate some of the features that DevWing Foam's got that are a bit unique to that, and make the build a lot more interesting and enjoyable. And possibly I'm going to put a flight controller in it as well. So I'm going to make a bigger wing and probably put iNav in, and I've been wanting to do that for a while. So keep a lookout for that. Thanks for watching, guys, and I'll catch you in the next video.